Hey everybody, welcome back. Here we are at the Red Barn, and we're going to keep chipping away at our Ferrari 360 swapped Porsche 914. And this week, I'm going to try to play it cool while I work on the water pump mount, but don't be surprised if I get a little bit wired while I'm working on the electrical system. Anyway, at the end I add some overview stuff about some mods I made to the jack contraption that a couple of you guys have asked about. So, hope you enjoy. All right, I had to make an update to the water pump mount, and the reason for that is, as you can see here, what I neglected to account for in my initial mock-up was I have to have a way to get the water to feed into this from the coolant tank, into the input to the pump from the coolant tank. And Mazir makes this fitting right here, which is this big old multi-AN8 O-ring fitted. There's 3 different positions on here, so wherever you clock this, you can probably get to somewhere that works for you. But this will be the input line coming from the coolant overflow tank that's going to sit back behind the motor, essentially, and I'll have a line that runs down and feeds the water into this fitting. But you can see what that did. It caused this fitting to move out, whatever that dimension is, but far enough that it's going to make getting the hose up here a little bit too tight of a bend. And anyway, so I wanted to remake the water pump mount, and this was the proof of concept, if you remember that, just the sheet metal piece. But now that I knew the dimensions, I went ahead and worked it up in 1/8" plate, which is it's plenty strong. But I'll see if I can show you what the difference is. If I line up the mounts, the mounting holes, you can see what I did. I just dropped everything down about 1 inch, right? And then, because I knew that this was going to be the final piece, I also moved, by the way, I also moved it out a little bit. If I show you, it's got these little bumps off on it, but you can see I moved it out about 1/2 inch too. And what that does is that just gives it a better shot. The line coming out from under the car, it gives it a better shot to where I want this to be, where the line's pointed at it. And so same slot and tab setup, but then I bent this nice little brace, and when this all goes together, it will sit, if I put it together on the right side, it will sit like that. And in all, that will be, as they say, going nowhere. So I'm going to go ahead and weld this up, and we should have the final piece ready for this thing to be mounted. Okay, here we are under the car, and right here, this little gap is where the radiator hose comes through. Here's the mount in place, and here's how this thing goes on. And I'm just gonna get that finger tight for right now, but this will give you the idea. And then, not that this is the right tube, you can see I just have to get this to jump up a teeny bit, and I think I'm gonna make a little step up tube right here. And I do have, it's hard to see, but I got like a skinny quarter of clearance between the back of this and the engine mount, and since this is all tied together, I'm not gonna move, so that clearance is fine. And I just have to get this hose to jump up a little bit to get into that fitting. So I'm going to go with that for now. Okay, here we go. It's wiring time. So I am set up on my table here with a couple things. One, which is super cool, is you can take this ECU and you don't even have to power it with 12 volts. You just plug in the USB cable to your computer and run the Haltech NSP. It's called the NSP software, and it talks directly to, you can see the go light is on, power light is on, and this talks directly to the computer, or to the ECU rather. And so what I've got here is I've just got the wiring harness. This is the raw wiring harness for the ECU with, again, the 25 amp, the 425 amp outputs, everything else. Nothing's plugged in, it's just set in place. And the first thing I'm going to do is go through and verify. Here's the pinouts for all the different connections and what those wires are for. And what I'm going through first to do is to separate out the stuff I know I'm going to use and identify the stuff I'm not going to use, so I can depin it and remove it from the wiring harness. And by that I mean, here's a good example. This is injectors for cylinders 9 through 18, or if you're running dual injectors or something like that, which I'm not. This is just a single injector per cylinder, so I only need, the injection for 1 through 8, and I only need ignition coils 1 through 8. So I'm just going to go through here and identify the stuff that I don't need. So I don't need any of these blue wires. These two wires you can see are the big deal 25 amp wires, which I will need to run other high draw stuff like the fuel pump, the water pump, fans, things like that. So quick overview of the software here that you might find interesting. Let me get you set up. Basically the way this works is there's a window about what you have going on in your engine, sensors, etc. And I'm not talking about any of the tuning stuff right now, right? I have no idea how that stuff works, which is why I'm working with a tuner. So there's a whole bunch of information about things I'm not anywhere near smart enough to get to yet. But this is what I can do relative to the wiring. If I click on this sensors link, what you'll see is there's a whole list of sensors that this ECU supports. And I have gone through and I have selected the ones that I need to use. Now there's a whole, talk about overkill. This thing's got capabilities way outside the scope of anything I'm doing. For instance, some of my favorites: wheelie bar pressure, right and left wheelie bar pressure, steering angle. You get over here into the boosted stuff, and it's got, here's all the turbo information if you're a nitrous person, blah de blah. All sorts of stuff in here too that I'm never going to use. And then if you're noticing all these error message, it's because anything that's in error over here is lit up in red, which means there's something either I haven't configured or it doesn't make sense or something's wrong. But I've gone through here and I've said these are all of the sensors that I need to worry about for this particular engine at this particular time. And what's nice is, as I said, when you choose one of these sensors and say, I'm going to use this, it puts it over here in this configuration window. And then you can come through it and it's relatively straightforward. For instance, I'm going to be running a map sensor. So I got a manifold pressure sensor. I chose it over here. And when I click on it here, it says, well, first of all, tell me which sensor you're going to use. And I've already done this, but what's super cool about this is it gives you a list of, it's not that these are the only sensors you can use, it's that it already knows about these. So to keep my life simple, I just went ahead and purchased one of the available ones here. I use this LS Gen 4 1-bar map sensor, and now that's in here. And so it knows what it needs to know about all that stuff. And then what I have left to do, I've already done it in this case, but you can see this one's red under fuel pressure because I haven't set up the wiring. But in the case of the map sensor, if I click on wiring, I have assigned it to this particular wire. Now, what's nice about this is it tells you when you're going through here, if I wanted to assign a different wire, it gives me access to all the different available wires. And what I now know is I've chosen this particular wire. It's white with a yellow stripe. That's what the W/Y stands for. And the C11 tells me which connector it's in. So if I take you off the tripod here and bring you over to the ECU, what you can see here is this is connector A, B, C, D, E. That's how they want to run this. So I know that it's in connector C, and it's pin number 11. So it's telling me exactly where to go, so I can chase from pin C, or excuse me, connector C. I can find the yellow and white wire, or the white with yellow stripe wire in there, and I know that that's my map sensor signal wire. And it's just that game all through here. So if you need me, I will be sitting right here playing with wiring for the next little while. So wish me luck, because as I say, I'm going in. As I get started with the wiring, I'm coming back to where I want to mount the battery, because I've been working with these big battery cables, and emphasis on the word big. They're big and they are certainly not light. And having a bunch of it running from the ECU location up, snaking around to getting to the battery up at the front, I'm then still going to have to run a fairly heavy cable from the battery all the way back down the car to the starter. And so what I'm thinking is I'm going to keep the ECU there, but I'm going to mount the battery right behind this wall, just like I did in the LS car, and it's going to go down in this location. Now, what it's important for you to know, well, important, if you aren't familiar with 914s, this bump out right here in this piece of the sheet metal is where the battery tray used to mount, and the big old lead acid battery used to sit right here. This area is affectionately referred to as the hellhole, because that battery would eventually overflow, water would go through the engine grill, it'd get on the battery would puke all over the place, and it would spill all of the acid water right down into that corner. And there was a little piece of sheet metal that I have since removed, but that created a little pond for all that nasty water. Then those two holes weren't ever there. Those were added to this chassis later. But what that would do is it would rust right through the top of the longitudinal, down inside the longitudinal, and take out that whole corner of the chassis. And it's a giant pain in the ass to get in there and repair that, because it's hard to get to, and there's multiple layers of metal in the longitudinals. And I think that's why it's referred to as the hellhole, because it's pure hell to repair the thing. But anyway, I am going to put a battery there. It's the same location where I put the battery in the LS, and in fact, I pulled the battery out of the LS. This is the battery cover, and I'm going to run the exact same battery. So it's going to end up being, somewhere about, it's going to end up being somewhere about here. Lower than the factory battery, but not, the LS battery, I think I have like way down in here like this. And the reason I'm not going to do it that same way is because you might have noticed there are those two holes down there. Those were added later, not by me, but I'm going to take advantage of them, because if you've watched all of these episodes and committed everything to memory, you would know that this oil line that runs from the low pressure return up to the air oil separator is temporary. There needs to be an oil cooler between these two locations. So this is just temporary to get the engine running. But eventually I'm going to need to run oil lines to the front of the car for a cooler, and I'm going to run them right through those two holes, because that gets me access. Those holes actually drop down and allow me to get right behind the rocker panel, this removable outer rocker, and I can run oil lines up the side of the car and then fish them around up to the front of the car to an oil cooler. So I need the battery to be high enough to get those oil lines to go under it, but I'll get it down as low as I can. So the first thing I need to do is make a tray for the battery to sit on, and then get that tray mounted in there. But first I got to make the tray, so let's go do that. All right, some of you guys have seen this already, but I'm just going to do a real quick run through. I've done a quick design up of a battery mount bottom, if you will. This is the battery hold down that I'm going to use, and so this is just a tray that the battery sits on, and 4 mount holes for this hold down to bolt to. And these holes in the middle will be opened up and made into some dimple dies to strengthen the base of it. But once I get the drawing done in here, and this product is called QCAD, then I open up a system called SheetCam. This is going to be the system that takes that DXF file and allows me to generate the instruction set for the plasma table to actually cut this. So I have to do things like tell it what thickness material and a few other things. And I go ahead and do that, and it knows how to set up, generate the tool path so that things are cut in the right order, etc. So now I ask it to generate that information, and I'm going to go ahead and do that real quick. And then I will open that file up into the system that runs the plasma table. This is Command CNC. And if I open up, that file, this is now the G code that's been generated by SheetCam, and it tells it, where to move the torch, when to fire the torch, when to lift the torch up and move it again, blah-de-blah. And I've already got everything squared up on the table. Let me just point you over here now. So I got everything on the table, all set and ready to go. And I'm going to go ahead and cut this now.
And you're going to see a bunch of smoke because I have the water out of the table right now. So ideally that's not what happens, but I got to clean everything out and refill the table. So it's going to be a bit smoky. I'm just moving the torch around to help have it blow this cooling air over the part, help it cool down. Normally it would be cool right after the cut because of the water in the table, but that's missing. So there's my part. I'm going to let that cool down for a second, and I'll be right back. All right, there's the part all cleaned up, and I have a little bit of a lip I want to bend up on the back and on the sides just to give it some strength. And then these holes, you're going to see here, I'm going to turn these into dimple dies in a second. But let me get this bend put in here first. That still allows that thing to sneak right into that corner. And so now I'm going to just bend up these edges. And just check it real quick. And that clears just fine. One more on this side. And our tray fits nicely in there, so yay, that part's done. All right, time for dimple dies or speed holes or whatever you like to call them. So what I had to do first was open up those holes. I like to just do it, go after it with a step drill. And I had to open it up big enough for this mandrel. And here's just a cheapy Harbor Freight punch. I don't know what this is. It's like a reverse press. It pulls this auger, this mandrel down into here. And what I'm going to do now is I'm going to make room for this 2.5-inch dimple die. These are Swag Off-Road dimple dies. And in order to get a hole this big, I'm going to use the Swag Off-Road Knockout Punch set. And what this is this cutter. And it works like this. You put that on there, and you put this on here, and you thread this down onto it. And then, with this hydraulic pump, it just pulls that cutter right through this material, as they say, like butter. And there is one hole. So I'm going to release this, and there's the slug that comes out of that from the punch. I'm going to punch the other one. Get that on there. Get that on there. And this is 18 gauge material. And that's that. So I've got my two holes, and then I use this same setup for the die. Now, the only important thing here is you have to remember which way you want your dimples to go, right? This is going to be the side that pushes the dimple down, so I want this one to be on the top. And you can see how that fits right into that knocked out hole. But that means this one, wah, goes here, right? And now I simply assemble this. Oops, look at that. I'm going to need more thread, because the difference here is I got to get something to thread onto this part. And all I use is just another one of the threaded. This is the Harbor Freight pipe size cutters. These are tube sized. And I just thread that on there. And I make sure that the tray tips up, which is what I want to capture the battery and the holder. And I want the dimple die to be pushed down. So now I'm just gonna crank this thing down into it. And what you're gonna see, if you can see it, is it's starting to deform the plate because it's trying to pull that material down. And one of the nice things is, once it gets, you can see it, well, I don't know if you can see it from there, but it's basically causing this side of the tray to bend. But once I get this surface down, it's got a nice big flat ring, and if I just keep going, and apply some serious pressure to it, it goes ahead and removes all of that distortion, and we end up with a lovely speed hole. Now, the other thing to be careful of when you're doing this is you can see that while the hole's only this big, the size necessary for the die is bigger. And there's a sheet that I worked up that talked about, for this size hole, how much room do you have to have for the die? And, right, I need to be able to do it next to this. So when I calculated, how I wanted to do this and could I get two 2.5-inch holes in here, I just did the math and it said, yes, you can. So I knew that I could have a dimple here and it wouldn't run into this. I have had times in the past where it didn't work out that way, right? So making sure I'm pointing it in the right direction. Oh, good God. Kind of uncoordinated today. Get this threaded on here. There's that. There's this. Let the smashing begin. And maybe you can see, I don't know if it's not showing the distortion that it's making, but then get it right to that point. Bottom this out. Release the pressure. Put all the tools back as you're going. And we have one dimple-dyed speed hold battery tray. And yeah, there's a teeny bit of an arch, but that's easy enough to go boop, and tweak that right back to straight, and we are good to go. So now I have to make a mount for this thing in the car, figure out what orientation I want it. But yeah, so how much weight did I take out of that, and how much strength did I add by tipping these edges and punching these holes? This is a nice, you know, I can twist it a little bit that way, but by the time I get the top on it and a mount on it, it's a nice tidy little battery mount base. So there you go. Knockout punches, dimple dies. Swag off-road. And then the next step on the battery mount was to add these studs that are just the fastening solution for the battery hold down mount like that. It's exactly the same way I did it in the LS car, and it works great. I will add a thin layer of rubber pad to this just to help protect and isolate the battery. And then obviously the next step is to work out the exact orientation and location of this thing and come up with a mounting system for it. But with that, I'm going to call it for this episode. So progress here, water pump mount figured out, wiring, a little bit of understanding about the software for programming the ECU and getting that all taken care of. So, hang around afterwards if you want to see a little bit about the jack contraption and some mods I made to that to make my life simpler. But in any event, everybody take care, like, subscribe, share, do all that great stuff, and we'll talk to y'all again real soon. Bye-bye. And now to something that's not build related at all, but that's super important to being able to work on this car and the LS car, and that is this jack contraption. A couple of you guys have asked about this, and as you can see, I'll tell you why I'm showing you this here in a second, but as you can see, it's just, you know, from sort of there to there is a regular ATV lift, and this red part used to bolt on back in this area, and it was a much more abbreviated sort of platform, and you can see I just hacked together an extension that allows me to have this whole table setup kind of thing. And what's happening is it works, you know, it works okay for the LS car, but this Ferrari build happens to be such that by the time you get that motor on here, it's just not quite, this is too tall. I can't quite get it low enough. It does work, but it's got like this much clearance over the top of the motor, and that's with the intake manifold and the air oil separator taken out. So at the very least, this is due for a rebuild, because it turns out these front wheels, they don't work great, and this thing's really hard to push around. So what I'm going to do, you can see this is in its lowest down position, and part of it's because this interferes with this, so this thing can't go down as far as it might otherwise go down. So the first thing I'm going to do is I'm going to lop this off on both sides so this whole cradle can sit down. So that should take it down about 1 inch. And then I'm going to cut this piece off and this piece off. Leave these, you know, these are pivotable. And I'm going to rotate that around to the front. And I'm going to move this level of the platform down to weld onto the front of this. as well as this up here. So I'm going to lose another 2 inches or so. I think that's, it's 1 3/4 inches. So in all, I'll be able to lower this whole platform down, a whole bunch, which will make life much simpler, and then I'll fix the front wheels. Okay, then partway through this work, I'm not going to bother showing you this because it's just hacking and welding and blah, blah, blah. So it's not that exciting. But here you can see the difference. Where this mounting point is now, it's on the back of this beam and on the back of this beam. It used to be down here. So I've lowered it, I don't know, is that 2 inches? I've taken it down a bunch. And then, yes, I still have, obviously, I've got interference stuff. I have to knock all this stuff off. But the other thing that's happening is I've got this support brace under here. And remember, this thing was just put together with leftovers, right? All this stuff was just leftover scrap. But this piece, which is a strengthening bar, I don't think I really need. So I'm going to notch it because it's interfering with this cross beam, preventing it from dropping down even lower. But then, as I was looking at it, it turned out, and like I said, I've already done all this, so you're not going to see it in process, but it turned out that the jack was actually bottoming out as one of the things that was preventing it from going lower. So I just extended, made a little H-bridge on both sides, and just extended this carrier so that this can fall farther, this thing angles down, and it can fall farther down before the jack bottoms out. So I'm just going to notch this thing to get it around that, and then knock off these tabs that you can see. That's going to interfere right here as well. So I just got to do a couple more mods, and this thing will be able to drop down much, much, much lower. I know this is not related to the build that much, but this is a really important tool for me. So I figure I'll cover this, and there you go. So next time you see it, it'll be all modified and ready to go. All right, well, I'm not quite going to finish the jack contraption. I did get the wider platform section done and just welded some 1x3 on there, and that keeps the Ferrari motor from rocking side to side. But new front wheels are going to have to wait. The only thing I could come up with was some much too big things that I had lying around. And I need some little ones to go down here because I don't want something that sits way outboard, and I don't want something that's cantilevered off the front that's going to be, in the way. So I just got to order something a little bit better than these, and I can see why this is so hard to move around. These things are just crap, and they're all worn out. They don't spin, they don't roll. But anyway, there it is, one updated jack contraption that now sits about 2 inches lower and is going to be more better for everything I need.